1877. That is the year the last full-strength El Niño on this configuration drove the Great Drought across India, China, and Brazil. A famine that killed an estimated 50 million people because the monsoon failed on multiple continents at the same time. Yesterday, the United States Climate Prediction Center issued an El Niño Watch with an 82% onset probability and subsurface ocean heat in the class of the strongest events on record. By the end of this report, you will understand how a careful, decade-long scientific warning and a live forecast have, this week, finally lined up what it means for the global food supply and why we should really start paying attention. Let's get into it. Yesterday, May 14th, 2026, the United States Climate Prediction Center, the federal agency that watches the tropical Pacific for a living, issued an El Niño Watch. The probabilities attached to it are not vague. 82% that El Niño conditions emerge during the May through July window. 96% that those conditions persist through the December 2026 to February 2027 winter. A watch is a formal alert. It means the conditions that produce an El Niño are now expected to develop, and the agencies and industries that depend on the forecast are being told to prepare. It is the federal government putting its name on a high-confidence forecast that the equatorial Pacific is about to change state. Most coverage of this announcement filed it as a weather story. A wet winter somewhere, a dry winter somewhere else. That framing is incomplete. The risk this watch actually carries does not land on a region's rainfall total. It lands on the global food supply, and it lands there because of a specific feature of how that food supply is built. A feature most of us never think about, and that the science of the last decade has shown to be a vulnerability the system was not designed to absorb. That is what this report is about. As of mid-May, the system is still officially classified as ENSO neutral. The most recent weekly temperature reading from the key stretch of the equatorial Pacific was somewhere around 0.4 of a degree Celsius above normal, still inside the neutral band. But the direction is unmistakable. The Pacific has spent more than a year leaning cool, in a sustained La Niña-leaning state, and now, for the first time in over a year, it has turned. The watch issued yesterday is the formal acknowledgement of that turn. One technical note matters. In February of this year, the Climate Prediction Center retired its longtime primary tool, the Oceanic Niño Index, and replaced it with a newer one, the Relative Oceanic Niño Index. The reason is that background ocean warming had been making the old El Niño threshold progressively easier to cross. The new index strips out that planet-wide warming, so the El Niño signal is measured cleanly. The takeaway, part of why the agencies are describing the current state through a watch and probabilities, rather than a single number that just flipped, is that the measurement framework changed 3 months ago. The underlying physical truth is unchanged. The strongest evidence behind the forecast is below the surface. The Climate Prediction Center reports that the index measuring temperature beneath the surface of the equatorial Pacific has now risen for 5 consecutive months. The mechanism driving that is a downwelling Kelvin wave, a slow, eastward-moving pulse of warm water sliding along beneath the surface, between 100 and 250 meters down. The water inside that pulse is currently running 6 to 7 degrees Celsius above normal. Multiple independent analyses describe that subsurface heat as comparable in magnitude to the onset phases of 1997 and 2015, the two strongest El Niño events on record. The fuel is loaded. What is still open is the atmosphere. For an El Niño to lock in, the equatorial trade winds have to slacken, and the ocean and atmosphere have to begin reinforcing each other in a feedback loop. Forecasters call that coupling. As of mid-May, the ocean has spoken. The atmosphere has only partly answered. That is the genuine uncertainty in this forecast. The Climate Prediction Center put the odds of this event peaking at strong or very strong, at roughly 2 and 3. Within that, the odds of a true super event, a sea surface temperature anomaly of 2 degrees Celsius or more in the key Pacific region, came in at roughly 1 in 3. That 1 in 3 super figure rose from about 1 in 4 just a month earlier. The odds of a major event are not holding steady. They are climbing. The European model, run by the European Center for Medium-Range Weather Forecasts, is the most aggressive of the major systems. Its forecast initialized at the start of May had roughly half its ensemble members exceeding 2.5 degrees Celsius above normal by October, with the ensemble mean pointing close to 3 degrees by late 2026. A value in that range would put this El Niño in the same conversation as the strongest events ever recorded. The World Meteorological Organization's multi-model average is approaching 1.5 degrees by midsummer, with a near unanimous upward trajectory. A note on what is circulating online. There is a wave of content claiming 100% certainty of a super El Niño, or unanimous model agreement. That is not what NOAA, the European Center, or the WMO actually say. The defensible version is this. A strong, possibly record-breaking El Niño is likely, peaking around the turn of the year, but the atmosphere has not locked in, and certainty is not on the table. The strength tier matters because a weak El Niño is a regional event. A super El Niño reaches across the entire Pacific Basin, an expanse of ocean spanning roughly a third of the planet's circumference, and pulls on the atmosphere over continents in all 4 corners simultaneously. The strength is what determines whether this is a weather event you read about, or a planetary event that touches the price of food on every continent at once. The core of this report, plainly, the global food system is built on a hidden assumption, and the science says the assumption is wrong. The assumption is independence. The unspoken belief that a bad harvest in the United States, a bad harvest in India, a bad harvest in Australia, and a bad harvest in Brazil are unrelated events, each its own roll of the dice. It is not a vague cultural belief. It is structural. Crop insurance is priced on it. The same diversification math that lets an insurer cover thousands of houses against fire, because not all of them burn down in the same year. National grain reserves are sized on it. International trade models lean on it. The architecture of global food security is built on top of the belief that the world's breadbaskets fail independently. In 2019, a study published in Science Advances took that assumption and broke it. The paper was by Anderson, Seeger, Bathgen, Kane, and Yu, titled Synchronous Crop Failures and Climate-Forced Production Variability. The researchers tested 4 major climate modes: El Niño Southern Oscillation, the Indian Ocean Dipole, Tropical Atlantic Variability, and the North Atlantic Oscillation. Their finding, all 4 affect crop variability, but only one of them, only one, can force globally synchronous crop failure. That one is El Niño. The numbers make it concrete. El Niño accounts for roughly 18% of the year-to-year variability in globally aggregated maize production. For wheat, around 7%. For soybean, around 6%. The largest synchronous crop failure in the entire modern record was the El Niño of 1983. The most important sentence in the paper is this. The researchers wrote that their finding runs counter to a central pillar of the global agriculture system, which assumes that crop failures in geographically distant breadbasket regions, such as the United States, China, and Argentina, are unrelated. A central pillar, the scientists' words. And the science says El Niño is the force that knocks it down. The natural question is how? How does a warm patch of equatorial Pacific water reach harvests thousands of miles away on multiple continents simultaneously? The answer has 2 physical pathways. The first is a single trans-Pacific atmospheric circulation pattern. Anderson and colleagues, in a companion paper published in 2018 in Agricultural and Forest Meteorology, traced it. Most of El Niño's effects on the world's crops trace back to one large atmospheric pattern that develops in late summer, persists into the following spring, and touches climate on continents in all four corners of the Pacific Basin at once. Not four coincidental disruptions. One disturbance with its fingers in four places at the same time. The same study estimated El Niño accounts for roughly 57% of the variability in wheat yields across North and South America combined. The second pathway runs through the jet stream. In 2020, Kornhuber and colleagues in Nature Climate Change examined what happens when the jet stream develops large, slow-moving meanders, what scientists call amplified Rossby waves. When that pattern dominates, the probability of simultaneous heat extremes hitting linked breadbasket regions rises by up to a factor of 20. A follow-up by the same lead researcher in 2023 in Nature Communications found something pointed. The climate and crop models we rely on do reproduce the wave patterns reasonably well, but they underestimate the surface damage. The official synchronized failure projections are not alarmist. If anything, they underwarn. A third independent line, Gaup and colleagues, also in 2020 in Nature Climate Change, used decades of production and climate extreme data and found the risk of simultaneous failure of wheat, maize, and soybean across breadbaskets is rising and is higher than independence assumption models predict. 3 teams, 3 methods, 1 direction. El Niño can synchronize. The models underwarn it. The synchronized risk is climbing. That is the physical machinery by which the watch issued yesterday could become a global food event. El Niño is not a blanket. It does not make every harvest fail. It produces a specific map of harvests that fail, and that map is the danger. The foundational study is Izumi and colleagues, published in 2014 in Nature Communications, covering the 4 crops that supply roughly 60% of all the calories humanity grows on cropland. Soybean is the consistent winner under El Niño. Global average yield improves 2 to 5% because El Niño favors the United States and South American soy belts. Maize, rice, and wheat fare worse. Global average yield change in the range of -4.3 to +0.8%. That range straddles 0. The global mean effect is modest. The danger is not the average. It is the correlation structure. Who fails together? The loss map. India and Southeast Asia, where rice and wheat suffer as the monsoon weakens. Australia, where the wheat belt dries out. Northern China, the Brazilian Cerrado, and Northeast. Southern Africa, where maize comes under pressure. Look at that list. Major exporters, major populations, and in the case of India and Southeast Asia, the largest rice-consuming populations on the planet. The loss map is, in physical terms, a monsoon map. The regions whose growing calendar depends on monsoon rainfall are the regions El Niño is known to suppress. The winter map is essentially 2 regions, the United States Midwest and southeastern South America, Argentina and southern Brazil. For maize and soybean, that is the cushion. The system's quiet expectation is that when El Niño pulls the loss map regions down, the United States and Argentina produce a surplus that flows out and catches the countries that are short. Some fail, some win. The winners cover the losers. The system holds. So everything depends on whether the cushion holds, which means the next question is what condition the breadbaskets are actually in today before the event has begun. The answer is uncomfortable. A strong El Niño in 2026 is not arriving onto a healthy, well-buffered global food system. It is arriving onto one that, in several of its most important regions, is already stressed. Start with the cushion, United States winter wheat. As of late April this year, the share of the crop rated good to excellent had fallen to roughly 30%. A year earlier, that figure was around 45 to 48%. Drought covered roughly 69% of the United States winter wheat growing area. More than 95% of the southern plains was in drought or abnormal dryness. The May 2026 United States Department of Agriculture supply and demand estimates forecast winter wheat production down 25% from the year before. We covered the broader drought picture in our recent video on the Florida fires. For today, the narrower point is that the cushion the world counts on is itself walking into the El Niño with a drought-hit wheat crop. The buffer, global grain stocks, is tightening. The May 2026 estimates put global wheat production at around 819 million tons, down from a record 844 million the prior year. United States wheat ending stocks projected around 18% below the prior year. Global corn ending stocks at their lowest level since the 2013 to 2014 marketing year. Ending stocks are the carryover, the cushion between one harvest and the next. They are why a single bad harvest does not immediately become a crisis. Right now, they are thin. And one structural change makes that thinness more dangerous than it sounds. Over recent decades, many countries moved away from holding large national reserves in favor of just-in-time food security. It works in normal years. It depends entirely on the independence assumption holding. A synchronized failure is precisely the scenario it has no answer for. The loss map regions are not waiting either. India's meteorological department forecast the 2026 monsoon at roughly 92% of the long period average, below normal, India's first below normal monsoon in 3 years. The reason given was, specifically, the developing El Niño. Indonesia's meteorological agency forecast that the 2026 dry season would arrive earlier than the 30-year norm and run drier. The agency advised farmers to switch to drought-tolerant crop varieties. Australia's forecasting agencies flagged below-average rainfall outlooks, with wheat production forecast down roughly 19% and cattle being sold off in record numbers ahead of the dry. The shape of it is hard to look away from. The cushion compromised. The buffer thin. 3 loss map regions on 3 continents, already adjusting before the event has officially begun. The mechanism is being handed an open door. All of this is happening on a planet that is also, completely independently, the hottest it has been in the modern record. That is not a side note. It is the amplifier on the primary mechanism. According to the Copernicus Climate Change Service, April 2026 was the joint third warmest April ever recorded, 14.89 degrees Celsius globally, 1.43 degrees above the estimated pre-industrial level. There is an international target, written into climate agreements, of holding long-term warming to 1.5 degrees above pre-industrial. A single month, April, in what is supposed to be a relatively quiet part of the year, is already pressed against that line, with the El Niño push still to come. The oceans are even more striking. April 2026 had the second highest sea surface temperatures ever recorded for the world's oceans outside the polar regions, 21.00 degrees Celsius. And critically, Copernicus reported record high sea surface temperatures across large parts of the tropical Pacific, the exact stretch of ocean where the El Niño is forming. Stage and actor are the same water. Independent analysis has 2026 on course to land as roughly the second warmest year on record, behind only 2024. There is an inversion worth flagging. In a typical climate record, the hottest years are El Niño years, the background trend plus an El Niño push. What is strange about 2026 is the order of events. The planet is at or near record warmth first, on the strength of the background trend alone, and the El Niño push has not even been delivered yet. The shove is still coming. This is the connection back to the central story. The same kind of synchronizing mechanism that has run before is being forecast to switch on over an already hot ocean and an already stressed food system. The heat does not replace the mechanism. It amplifies it. The synchronization science is not theoretical. The mechanism has run at full power before, and we have one full-strength, real-world demonstration of what a strong El Niño can do to the global food supply. It is the year 1877. The Great Drought of 1876 to 1878, also called the Global Famine, killed an estimated 50 million people or more, a figure drawn directly from peer-reviewed climate science. India's Great Famine of that period killed somewhere between 5.5 and 10 million. In northern China, in the Incredible Famine, the death toll ran from 9.5 to 13 million. In Brazil's northeast, in the Grande Seca, roughly 2 million died. In the same window, drought struck Ethiopia, Sudan, Egypt, Korea, Vietnam, the Philippines, Java, Southern Africa, and Morocco. The wider 30 to 60 million figure that sometimes circulates is from Mike Davis's 2001 book, and it is his aggregate across 3 separate famine episodes. For the single event, the figure from the climate science is exceeding 50 million. The defining feature was synchrony. The monsoon failed across multiple continents at the same time. There was no surplus region anywhere to move food from. The whole planet was the inside of the famine. In 2018, a paper in the Journal of Climate by Singh, Seeger, Cook, Kane, Ting, Cook, and Davis identified the configuration that drove it. The team called it a triple whammy. A record-breaking El Niño in the tropical Pacific, primed by a preceding stretch of cool La Niña-like conditions. Note the parallel to where we sit today. An extreme positive Indian Ocean dipole, the strongest ever recorded, and a record-warm North Atlantic. According to an 800-year tree ring drought record, monsoon Asia experienced the single most intense and second most expansive drought of the last 800 years. The lead author, Deepti Singh of Washington State University, framed the finding in a sentence that should travel forward. She said the study showed that the stage was set for a reprise of the worst known drought and famine. Not a prediction. A statement that the configuration is physically possible, and the climate system can re-enter it. The stage, she said, is set. The mechanism is real. It has happened. And the question now, back to the watch issued yesterday, is whether we are watching the early phase of a configuration that could reassemble. Before the close, the most important sentence in this report. A literal repeat of the 1877 death toll is not the probable 2026 outcome. The reasons are real. In 1877, there was no early warning. Today, there are thousands of instruments in the tropical Pacific feeding data in real time, and the watch issued yesterday is itself proof the warning system works. There was no meaningful international relief apparatus then. Today, however imperfect, that capacity exists. And the colonial-era political structure that turned drought into mass death does not exist in the same form today. An El Niño rivaling the 1877 ocean event is plausible. A humanitarian catastrophe on the 1877 scale is not the probable result. The realistic 2026 risk is different in kind. It is a synchronized food price and supply stability shock, landing hardest on the poorest, most import-dependent countries, the ones with no cushion of their own. The reference class is the food price episodes of 2007 to 2008 and 2010 to 2011. Nobody starving in the 1877 cents, but staple grain prices spiking and the consequences rippling through dozens of countries. The honest counterweight every forecaster is attaching, the spring predictability barrier. ENSO forecasts issued in boreal spring have historically lower skill because the coupling between the ocean and the atmosphere is at its loosest point in the annual cycle. 2014 and 2017 are the cautionary years. Both had spring model output pointing at a strong El Niño that never fully developed. The watch issued yesterday is a serious forecast, and the spring barrier is real, and both are true at once. What we will be watching over the coming months. First, whether the atmosphere couples this summer, the trade winds, the wind burst signal, real confirmation later in summer when the coupling has tightened. Second, the monsoon forecast revisions out of India's meteorological department as the season begins. Third, the United States winter wheat ratings as harvest approaches and the spring planted crop conditions through summer. Fourth, the global grain stocks as carryover figures come in. And fifth, the Indian Ocean dipole, the wild card. In 1877, a positive dipole deepened the catastrophe. In 2026, a positive dipole arriving in late summer could partly offset the second half of the Indian monsoon. Same feature, opposite role, depending on the surrounding configuration. The uncertainty in this forecast is about the timing and the magnitude. It is not about the mechanism. The mechanism is settled. The science of the last decade has shown it. 1877 proved it. And the watch issued yesterday is the moment a careful decade-long warning and a live forecast finally line up. We will be tracking it.